Hello everyone, welcome to the lecture series on IC applications. I am Siva Ramakrishna, Assistant Professor in ECE. In this lecture, we are going to discuss the topic on data converters. The contents of this presentation includes introduction to the data converters, what is the need for data converters, why we need to perform data conversion, that is from one form to another form, and then various types of data converters. And also we are going to provide a brief introduction on data converters such as digital to analog converters and analog to digital converters. If we look at the trend in the case of data conversion, which means what is the need for what is meant by data conversion? Data conversion is nothing but it is a process. It is nothing but a process of changing or converting one form of data into another form. So in general, we have various types of data. The data can be in the form of analog or it can be in the form of digital. So these data converters perform converting data from one domain to another domain. So that is from, if a signal is available in the digital domain. In some applications, we need to convert that digital signal back to the analog. That is, in general, we will call it as analog signal is an abundant signal, which is the original form of any signal. And in some other applications, we need to convert analog data back to the analog data to the digital form, that is analog to digital form. And also wherever we consider data processing, especially in the communication system or in the field of communication, we have only two types of data. What are they? The data can be either in the analog form or it can be in the digital form. So that is what we have. In general, we have signals. Our data is purely of two types. It can be analog data or it can be a digital data. The best example is nothing but our communication system. Also, the converter which converts analog data into digital data. So we can say that the data converter is nothing but an interface. So it is an electronic circuit or some kind of provision. It is a provision that converts data from one domain to another domain or one form to another form. So here we are going to say that the converter, let us say it is an interface which converts analog data into digital data, is called an analog to digital converter, nothing but analog to digital converter. The interface which we use to convert analog data to digital data, we can call it as a ADC, that is nothing but analog to digital. And we also have the converter or an interface which converts digital data to analog. At the moment, let us say we have the signal or data in the form of digits. So what is meant by digital data? These things we will discuss as we proceed in the lecture. So now what is meant by a DAC? DAC is nothing but an interface, any circuit which converts the data in digital form to analog. That interface can be named as digital to analog converter. And then let us look at the real world quantities. In general, so what is a real world signal? So which is abundant in nature? For instance, the voice signal. Voice signal is the best example for a data. Voice is also a data. What is the nature of this voice signal in general? It is nothing but an analog data. So that is what the real world quantity, that is the nature of the real world signal, is generally in analog form. And when one can represent these quantities electrically as analog signal. The best thing is nothing but a transducer. What a transducer will do, will take that a non-electrical signal and convert that into an electrical signal. So the output of this transducer can be an electrical signal, nothing but our mic. So in any audio system, if we have a mic, the mic, what is the input to the mic is nothing but a non-electrical signal, voice signal. So the transducer will convert that into analog form with certain volts, nothing but certain quantity of that signal. So what we can say, so in general, the real world signal is purely in analog nature, and these analog signals are usually represented or expressed in terms of what we can say, electrical signals such as volts. We can say that the signal may be of millivolts, or it can be some volts like 2 volts or 3 volts or 4 volts, right? And now let us consider the analog signal alone. What is meant by the analog signal? Analog signal is, in general, the form of this analog signal, how it looks like. The analog signal looks like, best example is nothing but our sinusoidal signal. If I draw a sinusoidal signal, I can describe 3 important parameters. What are they? The time at which it is going to travel and the magnitude at which it is going to occupy. So what is the magnitude of the signal above the origin and below the origin? So that we can call it as an amplitude. So these are the 2 quantities that one can find easily. Physically, with our naked eyes, one can notice these 2 quantities from any analog signal. Now what we are going to define here? What is meant by an analog signal? Analog signal can be a sinusoidal signal, right? So what it is going to have? It is nothing but a time varying signal. In general, the analog signals are time varying signal, and how the signal is going to vary? The signal is going to vary continuously. So this we will call it as a continuous. The signal is going to vary continuous with respect to the time. So that means one can define the time period of the signal which is going to repeat, with which it is going to repeat. We will call it as a periodic signals. Analog signal, that where the period of the signal is continuous over the time, can be called as a periodic signal. Also we have signals, so where the signals are continuous in time domain and the period of the signal may be varying, or nothing but aperiodic signals. Anyway, that is not the discussion of this lecture. So here we are going to define the nature of the analog signal, which is going to vary continuously with respect to the time. That means at any time instant. So here I am going to define my analog signal. Let us say this is the analog signal, or so let us express the signal. So this is, let us say this is my origin, and here I am going to represent the signal. Let us say this is the sine wave, and here I am going to represent the time, and this is going to be the amplitude of the signal. Now what we are going to say, at any time instant, here I can say a time instant, this is another time instant, say this is, so at any time instant, we can determine the magnitude of the signal. At any time instant, we can define the magnitude of the signal without any external effort, without any additional effort. So wherever you want to determine the magnitude of the signal, you can determine, because it is continuous in nature and the signal is varying continuously with respect to the time. Such signals are called as analog signals. Such signals are usually called as analog signals. And then if we look at the other form of the signal, or data, is going to be the digital signal. What is meant by the digital signal? So these digital signals varies from one level to another level. So here, for instance, I can draw a signal like this. So here I am going to define a signal with 2 levels. What are the 2 levels? So the signal has only 2 levels. So let us say this is plus V and this is going to be minus V. So this is an example for a digital signal, what I can say. So whereas here the signal has multiple levels. In the case of analog signal, the signal possesses multiple levels with respect to the time. Whereas here, the signal levels are going to be very strict. So they are going from one level to another level. And again, if you see the next transition of the signal, so the signal may appear like this. So in the next time instant, the signal will move to this direction. So this is the nature of the signal. So what we are going to observe here, once again, if you say this is my time, the x-axis is going to be considered as a time. So we'll have only two levels at any time instant, and here that's what, one level to another level, and we'll have only finite number of values for a given time slot. For a given time slot, these digital signals are going to have finite number of values, unlike analog signal. So what we said in the case of the analog signal, where whatever the time instant we consider, one can determine the magnitude of the signal throughout the time period. Whereas here we have only two levels in this particular representation, or in this figure, right? Now let us look at the application block diagram of this data conversion, where we are going to use this data conversion like analog to digital, or it can be a digital to analog. Let us consider a plant where the plant is going to generate some kind of signals. The plant is going to generate some signals. Let us say they are non-electrical signals. The plant is going to generate signals which are going to be non-electrical signals. And immediately, so what we are going to do here, in order to capture these signals, we are going to use a transducer or a sensor, right? So let us consider a plant. This is nothing but a plant, or nothing but a source for generating the signal, and this is going to generate some signal. The plant is going to generate some signal. In order to capture this signal, what we are going to use? We are going to use a transducer. So what is the purpose of the transducer here? So which will convert non-electrical signal to electrical signal. So what we are going to have here, the output of this transducer is nothing but an electrical signal with some magnitude, let us say some volts. The output of this transducer is going to be the signal with some kind of magnitude expressed in terms of some volts. So this is the output, right? So previously the signal does not possess any electrical representation. So the signal that is generated from the plant. So with the help of this transducer, we are able to convert that into a electrical signal. And now look at this interesting block. So what we are going to say here, I am going to use a filter. Now the form of the signal obtained at this level is going to be the analog, right? We are going to convert this, the output of this transducer is preferably an analog signal with certain magnitude. This is applied as input to the filter. What is the purpose of this filter in this block diagram, in this specific application? That too, we name it as an anti-aliasing filter. So if at all is there any high frequency components, let us consider a voice signal. We are going to capture voice signal. So generally, what is the nature of that voice signal? It is going to be a low pass. It is going to, the frequency components present in that voice signal are going to be very small, nothing but low frequency signal. If at all is there any kind of high frequency components, one can easily filter out, and then we can apply this as an output to the next level. So what we are going to do here, the output of this transducer is applied to a filter in order to get the interest of the signal. What is our interest? We consider a voice signal. In general, the frequency components of the voice signal are going to be very small. If at all is there any high frequency components are going to be filtered out with the help of this filter, anti-aliasing filter, and also if there are any overlapping samples present in the data, analog data can be separated out, right? We can filter out all these nuisance components present in the signal. Now look here, for some reason I need a digital data. For some reason I need digital data. What is that reason? I'm going to process it. I want to use this analog signal to my I want to apply this analog signal to a computer, or I'm going to perform like a digital signal processing approach. I'm going to perform an application called digital signal processing. For that, we need to convert this analog signal to the digital data. We need to convert this analog to a digital data, analog data to a digital data. Why? Because even if you consider the digital communication, we want to perform a digital communication, I need to work with digital data. If you want to process this data using any processor, what we need? Then no longer these analog signals are going to be operated. What we need now? We need a digital data. So to perform that, to achieve the digital data, immediately we are going to get this, we are going to perform analog to digital operation. So what is input to the block analog to digital data? So here I am going to have analog signal, so which is filtered, removed by removing all the nuisance components present in the data. Now I am going to perform this operation called analog to digital conversion. Now the output of this block is going to be digital data. It is purely, now the nature of the signal is going to be digital. So what is the nature of the signal? Digital, which is going to be ones and zeros. Now the data is expressed in the form of binary values, are nothing but ones and zeros. So these are going to be obtained in the output stage. The output stage of this line, starting from the plant to this path, here I am going to obtain this digital data, which is in the form of ones and zeros, are nothing but binary values. So these are going to be used to perform some application or to process in any kind of application or any specific operation. Let us consider I want to use this digital data to my computer, or I am going to perform any digital signal processing application. Not only these two, there are many applications where we are going to use digital data. In those applications, analog signals are no longer valid. In all these instances, we need to convert that existing analog data back to the, existing analog data to digital form. Right, I did some application. My job is done. So maybe I process this voice signal. I want to perform some, I want to smooth this voice signal, or I want to improve the quality of the voice signal. For that, I have processed this voice signal through my processor, nothing but a DSP processor. I have done. Now what we are going to do here? After this block, so what we are going to get? The application or job done. Right. Now what is the nature of the data? What is the output of this block? Still the data is in the digital. Still the data is in the digital form. Right. See, humans are sensitive towards the analog data only. We cannot understand or we cannot read a digital data. So what is the meaning for this? If I say 1 0 0 0 1 0 0 1 1 1, it is very difficult to read and sense the meaning and representation of this digital data. So initially I want to perform some operation with the existing analog data, so that I process this data through a processor. Example, nothing but our computers. The job done. Now I need to convert this digital data back to analog, because humans are sensitive towards the analog data only. They can understand our audio, video, all are in the form of analog data only. Right. So you want to improve the resolution, you want to improve the quality of an image. Right. The job is done. Then we are going to use the interface or block called digital to analog converter. I got the signal, which is I got the data. So what is the nature of this data now? The data is in the form of analog. With the help of digital to analog converter, we are able to convert the processed data back to the analog. Understand? Now the data is in the form of analog. So which is ready to use. It can be an image or video, right? Then this analog data is again applied as input to the filter, nothing but smoothed filter. So what is the purpose of filter? Once again, the same. What is the purpose of this anti-aliasing filter? So at both the ends, if you look at this block diagram, overall block diagram, we can say that this is my transmitting station or transmitting path, and this can be understood as a receiving path. So this can be understood as a transmitting path, and this can be understood as a receiving path. So that means the output of this receiver is applied as input to the humans. So here I am going to take this input. So if there are any nuisance components, once again, nuisance components present in this analog data due to the processing as well as conversion of this digital to analog, if at all is there any nuisance components, we need to make it smooth in the form of the levels of the signals or in the form of the frequency components. If there are any additional frequency components, they do generate because we are going to perform a complicated operation. We are going to perform a complicated operation at this level using a processor. It seems to be a single block, but this block is going to be very challenging. Because of this, other frequency components were introduced along with the original signal. Also, we are going to convert this digital data back to analog. In order to overcome all this, any additional frequency components or nuisance components and any different levels are varying at randomly at nothing but the data is in the form of analog. The data is in the form of analog, but the signal is not in a proper form. Then what we need to do? We need to use this smoothing filter to polish the signal. So this smoothing filter, what is going to do? It will polish the signal according to the requirements. According to the requirements, or in order to get back the original signal. In order to get this original signal, we need to perform additional filtering. We are going to perform filtering activity also. So that is what the operation or requirement of this smoothing filter, and this can be applied back to the plant. So this is starting from, this is nothing but a starting point, and once again this is going to be the end point. So finally I am the generator, I am the user. I am going to generate my voice input. I am going to hear, I am going to listen my voice, right? At both the ends we need a kind of conversion. So this is what the thing where we can go for this data conversion, because I am the source where I am going to generate, and at the another day I am going to use my data. Example, listening a music, watching a movie, any video or audio image, audio or video signals, right? So we need both analog to digital converters as well as digital to analog converters. So this is a simple block diagram that illustrates, so what is it? The application of AD as well as DA converters. And now let us look at this. So these are the fundamental blocks and explained here. So we have a transducer circuit, filters and conversions in both the ends, right? And now these are the common blocks. Whatever we have discussed here are the common blocks that do exist. That do exist in any platform. So where we need the conversion, that is analog to digital as well as digital to analog. So analog to digital is performed for the purpose of processor or any computer applications. And again we are going to convert the digital data back to the analog. So this time it is for humans. So we are sensitive towards this analog data only. We are not sensitive towards the digital data. So look at the essential. What is the requirement of this data conversion? Why these techniques are desperate in this technical era, in this technical world? Why they are going to play a major role? So we already have covered some content, so that will give the significance of this. So what we can say, if we want to connect output of an analog circuit as input to a digital circuit, so the circuits are available, right? We have analog circuits as well as digital circuits. So what we are going to do? I want to interface. I need an interface to process my analog signal, to process my analog signal to a digital circuit. So this is nothing but a digital circuit. How can I process this analog signal directly to a digital circuit? I cannot. So what we need? We need ADC. We need to convert this analog data to digital, right? This is one essential aspect of this conversion. Also, the interfacing circuit that converts analog signal into digital signal. Analog signal to digital signal. So here, this is my analog signal and this is my digital circuit. Let us say this is my digital circuit. Since I cannot process directly, I cannot process this analog signal directly to the digital circuit. I cannot apply this analog signal directly to a digital circuit. What we need? We need an interface. So here is an interface. So this interface takes this analog signal as input and will convert the data into binary. Nothing but digital, ones and zeros and ones and zeros. So this interface is called ADC, right? The interface which converts the analog signal to the digital is called ADC. So this is what the requirement. Unless I convert this analog signal to digital, I cannot process it or I cannot apply the signal to the digital circuit. And similarly, so look at the other end. Look at the other end. What is going to happen here? If we want to connect, these digital circuits are going to perform some operation. These digital circuits are going to have done some job. Now what is it? The output of this digital circuit acts as an input to the analog circuit. So this is so what we have seen in the plant example, right? So what is it now? The digital circuit is ready to produce the output, and then we need to convert that back to analog. We need to convert that back to analog, or otherwise there is no meaning for ones and zeros. So because they are not comfortable. This data is not comfortable to the humans. So what we need? Let us say this is my data, as I told you, 1 0 0 0 1 1 0 1 1. So this I want to consider applied as humans. I am the user. I am the end user. Since I cannot understand, or humans cannot understand this digital data, once again we need an interface. The interface is nothing but, this time this interface will take this digital data as input and will convert that to any analog signal. Will convert this to an analog signal. That interface will be called as a DAC, digital to analog converter. So what is the meaning here? The digital circuits produce some kind of output, digital data, and if we want to use it in the real world, the digital data is a challenging one. One cannot understand this digital data. So we need an interface. We need an interface that can convert this digital data to analog, back to analog. So this is the output of this DAC, and we have seen the output of ADC. We have seen the output of ADC, which is, so say this is my analog signal applied as input to ADC. So what is the output? The output is going to be in the form of digits. We is going to have only two levels, right? So the output of ADC is a pure digital signal, and the output of DAC is analog signal, right? Now let us look at the data once again. So what are the various forms of the data? So there are only two forms of the data in general. In terms of the real world applications or real world operations, we consider the data. The data can be either digital data or analog data. Now, what are digital data? They are evenly spaced and discontinuous values. What is the meaning here? They are not going to possess the values at every time instant. Understand? Now, they are temporally discrete and quantitatively discrete. So, we can hear the word called discrete. The basic nature of this digital data is going to be discrete in nature. It is not continuous. Unlike analog signal, what is the nature of the analog signal? One can define the magnitude or the value of the signal at every time instant. Whereas in the case of digital data is not like that. Definitely it is going to be evenly spaced. So that's what we said. So this is an example for a digital data. One can call it as a digital data. So what is it now? So here it takes only two levels and are evenly spaced. So that means the nature of the signal is a discrete. Understand? Of course, two levels, right? And then coming to the other form of data, which is abundant in nature, which is readily available. Best example is going to be the voice data, voice signal. So what is this signal? What is the nature? What is the nature of the signal? It is going to be continuous in range. The nature of the signal is going to be continuous and also temporally continuous, quantitatively continuous. So in the case of analog data, the word continuous will repeat several times. In the case of digital data, the signal is of the nature discrete. The signal is purely in the form of discrete. In the case of analog, in all the aspects, the signal is going to be continuous in nature. That's what we said, temporally continuous, quantitatively continuous. So if you want to see the magnitude, continuous in nature. If you want to see the time, also continuous in nature. So these are the basic forms of the data. Mostly, in most of the applications in real world, we access the data which can be either in digital or it can be in the analog form. Now, look at this one. The electronic circuits which can be operated with analog signals are called analog circuits. We are going to illustrate the circuits with respect to the signals or data. So what are they? We can design analog circuit or we can design a digital circuit. Now what are analog circuits and what are digital circuits? So these analog circuits are going to operate with analog signals only, which means it takes the input. What is the nature of the input? It is going to be analog in nature. And coming to the digital circuits, they are going to operate with digital signals only. That means it takes the input and the data and the signal is going to be in the form of digital in nature. The signal will be in digital nature, right? And now the data converter is again an electronic circuit. So we have seen two types of circuits. What are they? We define analog circuit. We define digital circuit in terms of the input output or in terms of the operation. Now what are ADC? Is going to be something else other than any electronic circuit. So this is what a data converter is, again going to be an electronic circuit that converts data from one form to another form, which means the data converters are not different from that of any electronic circuit. What is the job? What is the role of these data converters? They are going to convert data from one form to another form. Example, analog to digital, or it can be digital to analog. These are also electronic circuits in nature. These are nothing but electronic circuits. And then we have, so this is what we said. There are two data converters. What are they? The circuit or an interface. The data converter, we define two ways. So data converter can be an electronic circuit. Also we can define it as an electronic circuit or an interface. Understand, data converter is going to be an interface, or it is nothing but an electronic circuit. So basically there are two forms or two types. What are they? It can be an analog to digital converter, or it can be a digital to analog converter in nature. Understand? So the interface or the electronic circuit can be either analog to digital converter, or it can be a digital to analog converter. So you can understand this as an interface or an electronic circuit, right? And now let us look at this digital to analog converters and what are analog to digital converters. And let us briefly review this. These two converters are techniques, and later we are going to call them as a technique. So what is it? Analog to digital conversion, ADC technique and DAC technique, right? So are in most of the situations or cases, they are popular as DA or DAC. We call it as these digital to analog converters are popular as DAC. So what are they? They convert digital signals into analog format, and then this is what a simple block or simple figure that represents the nature of this digital to analog converter. What is going to happen here? So this is input. This is input to the DAC, and this is going to be the output. So what is the operation here? What is the basic operation? We have two converters. We have two types of converters, nothing but data converters. What are they? Digital to analog converter is the first one. That is nothing but it takes an input data, preferably in parallel form, right? So, and what is the nature of this input data? Purely binary. There is no excuse. There is no excuse to represent the data. It should be strictly a binary data, nothing but a digital data applied as input to this circuit or an interface. It can be a circuit or an interface applied as input, right? And now what is the output of this interface or electronic circuit? Nothing but analog signal, and if you look at it, it is going to be continuous in nature. The signal is continuous in nature. That is the input and output. So DAC interface will accept this digital data and produces the analog data as output. Now what are the applications where we are going to use this interface or digital to DAC circuits? So best example is nothing but CDs, and then 1-bit audio conversions, and then digital video, right? So where we have the audio and video are in the form of digital data. So for the benefit of the humans, we need to convert this digital data back to the analog. So in the compact disc, the data stored in the form of bits or bytes, right? Now we need to convert this data back to the analog. Only then we can listen the music or we can see the picture, right? And then in almost all the communication equipments, so that is the mobile phones, fax, right? And no doubt all the PCs, they currently work with digital data. As the output, they need to convert the operated data, the output data back to analog, right? And also in the case of some measurement instruments like programmable power supplies, these are all operated initially with digital data, and as an output we need to convert that back to the analog. Coming to the another form of the data, another form of an interface or another form of digital circuit, data converter circuit, nothing but ADC. So this is popular as ADC. So what is it? Analog to digital converter. It is a device, an interface, or it can be a circuit that converts analog signals obtained from the nature, nothing but environmental or in the form of physical phenomena, to the digital. Best example is nothing but voice. Voice signal is nothing but an analog. Voice signal is in the form of analog. So we need to convert this signal to digital. We have seen the reasons. I need to improve the quality of this voice. I need to improve the quality in terms of audibility, right? In terms of several features, I need to perform some operations over this analog signal. I need to process this signal. So it requires nothing but it requires conversion. It requires conversion. So what it is going to do? An analog to digital converter interface, how it is going to convert? So if we apply an analog input, we are going to get ones, zeros, or ones and zeros like this, digital data. So what are the basic steps involved in any kind of ADC? So we are going to perform sampling. So what is by sampling here? Since initially the signal is in analog and continuous in nature, so that we need to split into samples. So the continuous signal is now becomes discrete in nature because of sampling. Preferably this sampling should be greater than at least twice to that of maximum frequency of the original signal according to the Nyquist criteria. So this will be the first step in any conversion, nothing but ADC, in ADC conversion. So we are going to perform sampling and then we are going to perform quantization. So we know the meaning for quantization. We need to quantize the levels. We need to quantize these levels, the sample here. I have a sampled signal. Now I need to quantize this with respect to different levels. And finally, these levels are going to be encoded. It can be considered as 1 and this can be considered as 0, again 0, again 0. So in general, these are the 3 steps do appear in any ADC conversion techniques. So what are they? Since the original signal is continuous in nature, so we need to sample it, we need to split into we need to make it discrete. We need to discretize this continuous signal and then we need to quantize the levels with respect to the levels, and then finally we need to encode the signal. That encoded signal will be now in the form of digital data, that is ones, zeros, and right, this is the digital data. Now coming to the applications where we are going to use this ADC, again digital audio workstations, sound recording, and then various pulse code modulation techniques, no doubt in all the digital signal processing techniques. So wherever we use these TV tuner records, microcontrollers, digital storage oscilloscopes, and in different scientific instruments like digital image processing or digital image systems, radars and temperature sensors, because they are going to work with the real data. All these applications, they are going to work with the real data, and by converting this real data back to we need to convert this real data into digital, right? So only then we can fulfill these operations, we can execute this task, nothing but digital image processing. Definitely I need to convert my analog to digital, only then I can process, I can improve the quality of this image, right? So these are the things we covered in this lecture, and in the next lecture we are going to go in detail in terms of the techniques, various techniques involved for digital to analog conversion, and various techniques available, the techniques available for analog to digital conversion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.